Welcome pre-cal students to the homework help video class. Let me get rid of this right here. That's not for you guys. There we go. Okay, welcome to the homework help video class, page 905, numbers 1 through 29 every other odd, 31 through 34 all, and then 37 and 39, excuse me. Let's go ahead and get started. Numbers 1 through 20, the first section simply say to expand. So let's get after it. X plus 5 to the fourth power. Now we could write those parentheses 4 times and do a ton of work, or we can do the method that we've been taught. Okay, so Pascal's triangle real quick would be what? 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1, and that would be for the second, third, fourth, fifth. So we're doing pretty good. I'll put one more row up here in case we need it later, and I will just carry this triangle around here with me wherever I go. Okay, let's see here. So x plus 5 to the fourth power would be which row? Let's see. Well, this row here is when it's to the second power, so we're looking for this row. Another way to know, let me tell you a faster way, I should have thought of this. Whenever you're expanding to the fourth power, remember you always have one more than the power term, so you're going to have 5 terms, so you're looking for the row that has 5 numbers, okay? Because there's a 4 here, add 1 to the 4, that's a 5. You're looking for the row that has 5 numbers. So there's our coefficients right there, 1, 4, 6, 4, 1. We can remember that, I believe. So let me go ahead and highlight that and get rid of it, and we'll be able to use that whenever we need to. Hold on one second here. All right, there we go. Okay, so let's get started. My coefficients were 1, 4, 6, 4, 1. There's my coefficients. And now let's go ahead and let's write our exponents. It's x to the fourth power. So my first term would be x to the fourth, and then x to the third, and then x squared, and then x to the 1, and then of course nothing over here. And then I would start in the second term with 5 to the 1, and then 5 squared, and then 5 to the third, and then 5 to the fourth. Okay, now notice how all of my terms, their powers add up to 4. 4, 3 plus 1 is 4, 2 plus 2 is 4, etc., etc. Now I'm going to put my coefficients in front here, and so what I have would be a 1 plus 4 plus 6 plus 4 plus 1. And now let's go ahead and simplify, and we're finished. 1 x to the fourth is simply x to the fourth. Here I have 4 times x cubed times 5 to the 1, or 5. So 4 times 5 is 20. So I would have 20 x to the third power. And then here I have 5 times 5 is 25. And then 25 times 6 is going to be 150. So I would have positive 150 x squared. And then over here I would have 4 times 5 to the third power. Now 5 times 5 times 5 is 125, times 4 would give me 500. So I would have 500 x to the 1, or just x, and then plus, and I should not have written this like this. I should have put a dot right here. It was very confusing. That's my fault. 5 to the fourth power is going to be 625 times 1 is still 625. So there we go. I mean, I'm not saying they're super easy, but what I am saying is that it's faster than writing out 4 parentheses and then doing all that work. Okay? All right, moving on to number 5. Okay, on number 5, this is not as easy as it looks because of this negative sign, so I'm going to be really careful. I'm going to come over here and put a equals x and b equals negative y, and I'm going to use a plus b. And then when I'm all finished, I will substitute x and negative y back in, okay? So here we go. A plus b to the fifth power. I'm going to put 6 blanks, and we're going to use Pascal's triangle. To get our coefficients, I put my 5 blanks real quick here. Let's see here. I think I'm going to pull up Pascal's triangle first. There we go. Let's get our coefficients. I'm dealing with the fifth power, so I want the row that has 6 terms, which is this row right here. So there's your coefficients for a plus b to the fifth power. 1, 5, 10, 10, 5, 1. Okay, so that's taken care of. Now we know we're expanding a plus b to the fifth power, so we want 6 blanks. 1, 2, 3, 4, 5, 6. I'm going to put my a first, so a to the fifth, and then of course a to the fourth, a cubed, a squared, a to the 1, and then I start with b in the second term. It's b to the 1, b squared, b cubed, b to the fourth, and b to the fifth. Good. And now my coefficients were 1, 5, 10, 10, 5, 1. And I got that from Pascal's triangle. Now, we can make our substitutions. Everywhere there's an a, I'm going to put an x, and everywhere there's a b, I'm going to put a negative y. So here we go. 1a to the fifth. Where the a is, I'm going to put an x, so that would simply be x to the fifth. Now here, I would have a 5, then parentheses, put an x for a, and then put a parentheses for b. We put a negative y to the 1 power. Now, be careful here, students, please, okay? It's 5 times x to the fourth times negative y. Please don't forget there's really like a negative 1 right here, negative 1y. Negative 1y to the first power is negative 1y. So 5 times x to the fourth times negative 1y is going to be negative 5x to the fourth y. Because 5 times negative 1 is negative 5, and then x to the fourth times y is x to the fourth y. Okay, let's simplify this. Here I would have a 10, and then a parentheses, and then my x for a. Now be careful here, and then a negative y for my b. Now, don't forget it's a negative 1y. When you square a negative 1y, that's a negative 1 times a negative 1, that's 1. And when you square a y, that's a y squared. So really, negative 1 y squared is negative 1y to the second power is going to be positive y. So I have 10 times x cubed times y, which would give me 10 x cubed y. Now we come over here, and where this a is, I'm going to put a little 10, and where the a is, I'm going to put an x, and where the b is, I'll put a negative y to the third power. That's really negative 1y. Understand, when you cube a negative 1, you get a negative 1, and when you cube a y, you get y cubed. So there we go. Negative 1y, all of that to the third power. Negative 1 times negative 1 times negative 1 is negative 1, and y to the third power is y to the third. So you have 10 times x squared times negative 1y cubed. That's going to give you negative 10 x squared y cubed. All right, let's go ahead and take a look. I'm going to get a little bit, did not mean to do that. Not sure what I just did. I hope I didn't mess anything up. Okay, now my next term here, I'm going to have 5, and then an x for the a, and then for the b, a negative y or negative 1y to the fourth. Now, when you take a negative 1 to the fourth power, that gives you a positive 1. And of course, y to the fourth is just y to the fourth. Okay, so there we go. We simplify that. 5 times x times 1y to the fourth would be 5x y to the fourth. And now we're down to our last term. It would be a positive 1, and then parentheses, the negative 1y to the fifth power. Now, when you take a negative 1 to the fifth power, that leaves you with a negative 1. And when you take y to the fifth power, you get y to the fifth. All of that is times a positive 1. So 1 times a negative 1 is negative 1. You don't have to put the negative 1 if you don't want to. You can if you want. Negative 1y to the fifth power. So there we go. Hope that's been a help to you. Let's move on to number 9. Let me get a drink here. And this one looks a lot more difficult, unfortunately. First of all, let's get our Pascal's triangle figured out. Looks like we might have to add a couple rows here quickly. We're taking 2t plus 1 over t to the seventh power, which means we need 8 terms. We have 7 terms here, so we got to do one more row. 1, 7, 21, 35, 35, 21, 7, 1. Let's see if that's right. 1, 2, 3, 4, 5, 6. Yeah, that's right. Okay, so I will try to just cut out those if I can. So there's my coefficients. All right, and let's go ahead and get rid of this here. And there's the coefficients I'll be using from Pascal's triangle. Now, I'm going to say that A equals 2t, which is my first term, and I'm going to say B equals 1 over t, which is my second term. And now I'm going to go ahead and quickly rewrite this as A plus B to the 7th power. All right. Now, that means I'm going to have to put 8 blanks. So 1, 2, be a tight squeeze, 3, 4, 5, 6, 7, 8. All right. So for my first term, of course, A to the 7, 6, 5, 4, 3, 2, 1, and then b to the 1, b squared, b cubed, so on and so forth. All right, there we go. Now, let's see. I have my coefficients here real quick. So 1, I have to squeeze these in, positive 7, positive 21, positive 35, positive 35, positive 21, positive 7, and positive 1. So it's going to be a lot of work, and we understand that, and that's just how it goes. So, all right, here we go. Let's make our substitution here. So I'm going to do my substitution here and then erase it. So I have 1a to the 7th. So I really have is 1 times 2t to the 7th power. Okay? So 2t to the 7th power means 2 to the 7th power, which would be 128. So I have 1 times 128, and then of course t to the 7th power is t to the 7th power. So my first term is 128 t to the 7th power. And I'm going to erase my work every time just to get more room to work with, okay? All right, let's take a look here at the next term. I would have 7, and then for a, I'm going to put 2t to the 6th. And then for b to the 1, it would be 1 over t to the 1 power, of course, which is just 1 over t. Now watch what I do. I have 7 over 1 times, now 2t to the 6th is going to be 64. 2 to the 6th power is 64. T to the 6th is t to the 6th. I'm going to put it over 1 because I then have 1 over t. Now, when I multiply all these together, first of all, notice my t is going to cancel with my t here, leaving me with t to the 5th. So for the denominator, I have 1 times 1 times 1. That's just 1. So I have 7 right here times 64 times t to the 5th. So 7 times 64 will give me 448. So a positive 448 t to the 5th power. All right, let me erase that work and let's try the next term. All right. All right, moving on to the third term. I have 21 a to the 5th b squared. So that would then give me 21 2t to the 5th 1 over t squared. That would then give me 21 times, now let's see, 2 to the 5th should give me 32. So I know 2 to the 5th would be 32, and then t to the 5th is t to the 5th. I'm going to go and put all that over 1 and put this over 1 times, well, when you square 1 times 1, that's 1. When you square t, that's t squared, okay? So you square the 1 and square the t. Cancel 2 t's out here with 2 t's here. That leaves you with t cubed. So 1 times 1 times 1, 1's in the denominator, 21 times 3t cubed. 21 times, that's a 32, I apologize. 21 times 32 t cubed. So 21 times 32 gives me 672. So I would put plus 672 and then t to the third power. We're almost halfway done, so hang in there. I know these problems are a pain. No one knows that more than I do. I totally get it, okay? But it's good practice, and I want to make sure you're ready for your test and quizzes coming up. All right, let's go to the fourth term. 1, 2, 3, 4. So we're going to have 35, and then a to the fourth. I'm going to put 2t to the fourth, and then b to the third. So I'm going to put 1 over t to the third. Now, I'm going to go ahead and next put 35 over 1, and then times 2 to the fourth power, of course, would be 16 t to the fourth. 2 t to the fourth would be 16 t to the fourth. Put that over 1. And then over here, you cube the 1. So 1 times 1 times 1 is 1. You cube the t. That's t cubed. Now, your t cubed would cancel with your 4 t's here, leaving you with 1t. So we have 1 times 1 times 1 for your denominator. For your numerator, 35 times 16t times 1. So 35 times 16 is going to give you 560. So positive 560t. There we go. Let's break out the eraser. Let's erase that, and let's move on now to term number 5. All right, we are now at 35a cubed b to the fourth. So I would have 35 parentheses, then 2t to the third power, and then 1 over t to the fourth power. So what that really means is 35 over 1 times 8t cubed over 1 times, well, 1 to the fourth power is 1 and t to the fourth power is t to the fourth. Now we got a little something different here. I'm going to cancel my 3 t's with my 4 t's, leave me with 1 t in the denominator. So what I would have now is a t in the denominator, and then 35 times 8. So 35 times 8 is going to give me 280 over t. Now we don't want to leave it like this. We don't want fractions if we don't have to. So it's t to the 1 power. And remember, I have taught you guys that you can pick up your denominator like this when it's 1 term over 1 term, and you can move it to the top as long as you change the sign of the exponent. So instead of having 280 over t, we now have positive 280 t to the negative 1. And I will expect you to do that on tests and quizzes, okay? All right, let's take a look at our next to last term. So we're trying to knock this out quickly, okay? Next to last term. Am I right? Did I skip one? I hope I didn't skip one. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So no, we're not on our next to last term. That was just kind of high hopes on my part. All right, 21 times a squared. That'd be 2t squared. And then b to the fifth. That would be 1 over t to the fifth. And by the way, I hope I don't make any mistakes on these. If I do, I apologize. I am going fast, and it can happen. You understand that. I do know what I'm doing, but we all make little mistakes. 21 over 1 times, well, 2 times 2 is 4, t squared is t squared. Put all that over 1 times, and then 1 to the fifth power is 1, t to the fifth power is t to the fifth. And now we can do some canceling. Cancel 2 t's here, cancel 2 t's here, leaving you with t to the third. So now in your denominator, 1 times t cubed is t cubed, and then 21 times 4 is going to be 84. So you have 84 over t cubed. Now we understand how we're going to write that is going to be 84 t to the negative third. All right, let's move on now to finally the next to last term, which is 7 a to the 1. That would be 2t to the 1, b to the sixth, which is 1 over t to the sixth. There we go. All right. I'm going to put the 7 over 1 times 2t to the 1 is just 2t, put that over 1, and then 1 to the 6th power is 1, and t to the 6th power is t to the 6th. And now I have 1t. You say, no, you have 2 t's, Mr. Art. No, there's a 1 right here. Look at your power. Cross off 1t with 1t. That leaves you t to the 5th. So it looks like your denominator is going to be t to the 5th, 1 times t to the 5th, and your numerator is 7 times 2 times 1, which is 14. So I'm going to squeeze in here plus 14 t to the negative 5. All right. And now we're just about done. This has been I knew it'd be a long assignment. I tried to make it as reasonable as possible. For these long problems, I've only given you 1, 5, 9, 13, 17. There's 5 long problems. You can handle that. And then the rest of them are much easier. Believe me, you're getting the 5 worst ones out of the way. Okay, we have 1b to the 7th power right here for your last term. So 1 parentheses 1 over t to the 7th power. So I really have 1 over 1 times, well, 1 to the 7th power is 1, t to the 7th power is t to the 7th. 1 times 1 is 1 for your numerator. 1 times t to the 7th is t to the 7th. And so your final answer is going to be plus. And if you want to put your 1, you can put your 1. That's fine. 1 t to the negative 7th power, or you don't have to put that 1 if you don't want to. So there's your answer. Wow, that was a killer of a problem. Let me get a drink here. And let's continue on, number 13. Okay, hopefully not as bad. Looks like it's a little easier. Not a lot of powers to deal with and stuff like that. And plus, we're only taking it out to the 6th power. Okay, let's get our coefficients first, if we could, please. We're taking the square root of 5 plus t to the 6th power. So I want the row that has 7 terms, which is this one right here. So it looks like to me, if I can somehow squeeze this out, looks like there's my coefficients. So let's pull those down there. And by the way, I knew to use that row, remember, because my power is 6, and I know if the power is 6, I'm going to have 7 terms. So I needed the row that had 7 numbers in it, and this row has 7 numbers. All right, also because I have a 6 here, I'm going to add 1 to that. I need 7 blanks. So 1, 2, 3, 4, 5, 6, 7. All right. And you know what else I better do? I forgot to mention this real small here. I'm going to squeeze this in. We're going to say that a equals the square root of 5, and we're going to say b equals t. Okay? And actually, to be dead honest with you, we really don't need to put a substitution for t. Now, if this would have been negative right here, you need to put a substitution for t. You would want to put b equals negative t. Whenever there's a negative sign there in that second term, you need to do that. But to be honest with you, I mean, since it's just t, I can leave it t. That's not a problem. But square root of 5, I'm going to substitute that in with a, okay? So I'm going to go ahead and put a to the 6th. So basically what I have here is a plus t to the 6th power. For square root of 5, I substituted a. For t, I'm substituting nothing. I'm leaving it t. And I can do that as long as in the end I put a square root of 5 in for a. So I have a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1. And then I would have a t here, t to the 1. And then we ascend with our powers. So t to the 3rd, t to the 4th, t to the 5th power, and then t to the 6th power. Notice all the exponents in each term add up to 6. Now I put my coefficients in, so 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1. All right, and now let's get started. Here we go. Everywhere there's an a, I'm going to put square root of 5. So my first term, I would have square root of 5 to the 6th power. And I wonder, I didn't look in the back of the book. Maybe I should pause the video and see how they want us to write our answers here. Okay, the back of the book does want us to not use decimals, so we'll leave it in radical form when we have to. But in this case here, to be honest with you, if you take the square root of 5 and you raise that to the 6th power, you're going to see you get 125. You can take your calculator and type that in. You'll see that. So the square root of 5 to the 6th power is 125. There's a 1 right here, so it's 1 times this. So we would get 125. All right, I'm going to keep erasing and just using a lot of space here. Okay, next I would have 6 times square root of 5 to the 5th power. and then of course t is t to the 1. Now, I want to be very careful here, and I want to teach you guys something. The reason that the square, watch this carefully please, the reason the square root of 5 to the 6th power came out to a whole number is because this was an even exponent and this was an index here of 2. It's a square root. Remember, if you took square root of 5 times square root of 5, you would get 5. Think about it. Square root of 5 times square root of 5 would give you square root of 25, which is 5. So square root of 5 times square root of 5 is just 5. So basically over here, when you add the square root of 6, when you add the square root of 5 to the 6th power, that's like writing the square root of 5 how many times? 6 times, right? And then square root of 5 times square root of 5 is 5. Square root of 5 times square root of 5 is 5. Square root of 5 times square root of 5 is 5. And then 5 times 5 times 5 is 125. Okay? So that's why that worked. So now let's apply that to this scenario right here. Okay? When I have the square root of 5 to the 5th power, that's really like having the square root of 5 squared, square root of 5 squared, and then square root of 5. That's 5 square root of 5. Square root of 5 times 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 square root of 5. Okay? And then 6. So that's really what you have right here. And then of course times t. So square root of 5 to the 5th power would be square root of 5 times 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 square root of 5. Now I just showed you square root of 5 times square root of 5 is 5. Square root of 5 squared, square root of 5 times square root of 5 is 5 times square root of 5. Well, 5 times 5 is 25, square root of 5. So what I have is 6 times 25 square root of 5 times t. We'll do some more of these. You'll get the hang of it. So 6 times 25 is going to be 150 square root of 5. So I have plus 150 square root of 5 t. That's it. Let's move on. Let's practice some others. You'll get the hang of this, okay? But we got to practice here. All right, let's go ahead and take a look at term number 3. I have 15 square root of 5 to the 4th t squared. Now square root of 5 to the 4th, you understand, is the same thing as having square root of 5 squared times square root of 5 squared. And of course, I just went over this with you. Square root of 5 squared is 5. Square root of 5 squared is 5. 5 times 5 is 25. So I really have 15 times 25 times t squared. All right. Now, if you type into your calculator 15 times 25, you're going to get 375. So I have a positive 375 t squared. Really, to be honest with you, not too bad, okay? Let's see if we can't circle in here and erase this without erasing the top or the bottom. Hopefully we can do that. Alright, there we go. Success. And we're going to slide this down just a little to make sure we don't run into that problem. Alright, now here we go. Next term, we're on the 4th term. So we would have 20 and then parentheses, square root of 5 to the 3rd power t cubed. Now square root of 5 to the 3rd power, you understand, is the same thing as having square root of 5 squared times square root of 5. I mean, that's like having 3 square root of 5. You have square root of 5 squared, so square root of 5 times square root of 5 times square root of 5. Now square root of 5 squared is 5. So really what you have left here inside the parentheses is 5 square root of 5. Bring down your t cubed, bring down your 20. Now 20 times 5 square root of 5 would be 100 square root of 5 t cubed. Okay? 20 times 5 is 100. All right, let's go ahead and see if we can't work on the next term, and that would be the 5th term, I believe. 1, 2, 3, 4, 5. So now we have 15 square root of 5 squared t to the 4th. Now, square root of 5 squared is just 5, so I really have 15 times 5 times t to the 4th, and 15 times 5 is 75 t to the 4th. So 75 t to the 4th. These are getting easier as we go along, which is good, of course. And now let's take a look at the next to last term. which would be right here. 6, 8 to the 1, so that would just be square root of 5 to the 1 power, and then t to the 5th. Now, the square root of 5 to 1 power is square root of 5, and 6 times square root of 5 would be 6 square root of 5 t to the 5th. And then your last term here is just 1 t to the 6th, so positive t to the 6th. You're welcome to put the 1 in front of the t if you want to. That wasn't too bad. It really wasn't. I think it was easier than the last problem. Let me get a drink here. And you know what? This is our last one of these really difficult problems, so way to hang in there. In the end, it's going to be a total blast. I'm kidding, of course. I'd like to skip this, to be honest with you. All right, here we go. Well, I think the wise thing to do is to forget this part of the problem and just pretend that we did it. I'm kidding, of course. I think we should skip that for now and just work with the first part. So right now, we're going to go ahead and put up our Pascal's triangle, and there's our 7 terms. So these are the coefficients we'll be dealing with. So let's go ahead and get our coefficients pulled up here. And this is going to be tough to pull this out. Yeah, we'll do it like this. There we go. All right, so here's our coefficients. This will be a doozy, but it's our last one, okay? So hang in there. You can handle this. And we're going to take, again, we're going to forget this part of the problem right here just for a second. We're going to deal with just this. So here we go. We're going to have 7 terms. So 1, 2, 3, 4, 5. I'm just going to erase this. I'm going to go ahead and just do, we've done so many of these now, students. I think you're ready for this. For this right here, I'm going to say A equals square root of 2, and I really don't need to put anything in for 1. 1 is just equals 1, so I'm going to say we're leaving 1, 1. So here we go. For my first term, I would have a coefficient of 1, and then I would have a to the 6th, and then plus, I'll put a check mark. Now I'll put a check mark here, plus 6. I have a to the 6th, so I would go down 1, a to the 5th, and then of course my 1 would be 1 to the 1 power, and then plus my next term would be 15, and then I'm going down with my a, so a to the 4th, and up with my b's, or my 1 here, so then I would have 1 to the 2nd power, excuse me, and then plus, and then I would squeeze in a 20 right here, so 20 a to the 3rd, and then 1 to the 3rd, and then plus 15 a squared 1 to the 4th, and then plus 6 a to the 1 1 to the 5th, and then plus 1 to the 6th power. Okay, so there we go. Now I think we can take this in a minute and use it for this over here to save us time, but for right now there's everything I have. Okay, now we're going to put the square root of 2 in for a. So I think we can do this actually pretty quickly. Okay, all right. But I don't want to lose you guys here, but I think we can do it pretty quickly. So I'm going to give you an extra page here. We're going to need it. There we go. All right. So I'm putting square root of 2 in for 6. So I have 1 times square root of 2 to the 6th power. Now remember, square root of 2 to the 6th power, just use your calculator. Trust me, if you type that in, I believe you're going to get out 8. I'm going to make sure with my calculator, but the square root of 2 to the 6th power is giving you 8. Yes. So square root of 2 to the 6th power is 8. So 1 times 8 is 8. There's my first term. Okay? Easy enough. Let's go on to the second term. The second term is going to be 6 times square root of 2 to the 5th power times 1. Now, trust me here, you have square root of 2 written out 5 times, right? It's 1, 2, 3, 4, 5. And square root of 2 times square root of 2 is 2. Square root of 2 times square root of 2 is 2. Bring down your square root of 2. 2 times 2 is 4. So you're going to get 4 square root of 2 times 1. All right? So 6 times 4 times 1 is 24. So a positive 24 square root of 2. All right, let's take a look at the third term. We would have 15 parentheses, square root of 2 to the fourth power, and of course 1 squared is just 1. Now, because this is an even exponent, I mean, you can type in your calculator. What you have is a square root of 4 written 4 times. So square root of 2 written 4 times. Square root of 2 times square root of 2 is 2. Square root of 2 times square root of 2 is 2. And 2 times 2 is 4. So you really have 15 times 4 times 1. Okay? And that would be 60. 15 times 4 is 60, times 1 is just 60. Okay? I think we're going to find this much easier than I thought, this problem here. All right, let's go on to the fourth term. We would have 20 square root of 2 to the third power times 1 to the third, which is 1. So I have square root of 2 to the third power, square root of 2, square root of 2, square root of 2. Square root of 2 times square root of 2 is 2. Bring down your square root of 2, so 2 square root of 2. So I have 20 times 2 square root of 2 times 1. Well, 20 times 2, the outside 2 is 40, times 1 is 40. So positive 40 square root of 2. So there we go. We are really cruising right along here. All right. Moving on to our fifth term. 1, 2, 3, 4, 5. So 15 square root of 2 squared. 1 to the fourth is 1. Now square root of 2 squared, that's square root of 2 times square root of 2, that's 2. So I have 15 times 2 times 1, and that's obviously going to give me 30. Okay? 30. Now let's take a look here at this next term. I would have 6 times the square root of 2 times 1 to the fifth, which is 1. Well, 6 times 1 is 6. 6 times the square root of 2 is just simply 6 square root of 2. And then we move on to our last term, I believe. Let's make sure. 1, 2, 3, 4, 5, 6. Yep. My last term is 1 to the sixth. So that's 1. Now, this is really much easier than I thought, students. Oh my goodness. Now watch this, please. Watch this. I've got like terms. I'm going to put check marks. I've got an 8, a 60, a 30, and a 1. So 60 plus 30 is 90, plus 8 is 98, plus 1 is 99. So I have 99 plus, now look at these like terms. I've got a square root of 2, a square root of 2, and a square root of 2. So I have 24 plus 40 plus 6. Now I'm not sure if you remember how to combine radicals, but as long as they have the same square root, you just combine the outside number. So 24 plus 40 is 64. Plus 6 is 70. All right, 46, 70. So you would have 70 square root of 2. All right, so all of this work came down to this right here. All right, so I'm going to bring this to the next page right here. Now, this thing right here, I'm going to circle it for you. This right here equals this right here. So what we're going to do now is put a minus sign and then a parentheses, and we're going to subtract out this whole mess right here. All right, so I better go here and do this real quick because I want to get rid of this circle there. So break out the eraser. I'm going to erase all of that. Actually, I'm not, because I might end up using that. And now I'm going to go on to this scenario here. Now the only thing that's different, we can really use this right here so nicely. This is identical to this, except we're going to have to say a equals square root of 2, and we're going to have to say b equals a negative 1. That's all that we're going to say. So everywhere that we see a 1 right here, we're really going to have a b. Okay? Do you see what I'm saying? There we go. So all that I did is I said square root of 2 equals a, which is what we did over here. So the a's don't change. And I'm going to say negative 1 equals b. So I put a b in. Now everywhere there's a b, I'm going to put a negative 1. Now would you listen to me? What used to be in this parentheses? Didn't there used to be 1s in these parentheses? See these 1s? Well, now we're putting b in for these 1s, and then we're going to put what in for b? A negative 1. So really, all of these 1s are just simply going to become negative 1s, because that's really what we're putting in for b is a negative 1. So all of these 1's right here now become negative 1's. It's probably not the best teaching method to do this, but it's really going to save us a lot of time. So all of these numbers down here are fine. All of these numbers are fine. I'm going to get rid of these x's and stuff and check marks. All of these terms are fine down here. The only thing that's going to happen is the signs right here are going to change. That's it. Nothing else is going to happen. Watch, students, watch this carefully. Like this term here stays the same, so I'm good. Now this term here, a negative 1 to the 1 power. So I would still have 6, and a to the 5th power is still going to be 4 square root of 2, which we found that earlier. We knew that from earlier. Now negative 1 to the 1 is negative 1. So when you take 6 times 4 times negative 1, you get a negative 24 square root of 2. So the only thing that's changing here is just simply my sign. So now, I don't know why I pulled that out. That didn't make a lot of sense, did it? So now my 24 square root of 2 is negative. That's it. That's the only thing that's happened. Now, let's go ahead and move on to the third term. And here, nothing changes. Let me show you why. We still have our 15, and we know that a to the 4th power is the square root of 2 to the 4th power, which is going to give you 4. We've already did that earlier. And negative 1 squared. A negative 1 times a negative 1 is a positive 1. So you still get a positive 60. So in that case, nothing changed because your negative 1 was being raised to a positive, not positive, an even exponent. So now we go to the next term. Now here my negative 1 is being raised to an odd exponent. Negative 1 times negative 1 times negative 1. So I'm going to have 20 times 2 square root of 2, which we already figured that earlier for a, and then times the negative 1, because negative 1 times negative 1 times negative 1 is negative 1. So 20 times this outside 2 times negative 1 is a negative 40. So the only thing that changes here is just the sign. So this is not near as bad as I thought it was going to be, really. So now I have a negative 40 square root of 2. All right, now let's continue on to the next term. All right, now my next term, notice my negative 1 is to an even exponent 4. Well, negative 1 to an even exponent is a positive 1. So I really have 15, and of course a squared is square root of 2 times square root of 2, which is 2, times a positive 1. So we get 30. Nothing changes. And by the way, when I get to the last term here, negative 1 to the 6th power is a positive 1. Nothing changes. The only thing that changes is this term right here. That's out of the terms that are left. That's the only one left that I have to change, because my 5, my negative 1 to the 5, my 5 is an odd number. So I have 6 times a to the 1 power, that's square root of 2, times, well, negative 1 to the 5th power is negative 1. So I have 6 times square root of 2 times a negative 1, that's negative 6 square root of 2. So the only thing that changes there is my sign. I want a negative sign. There. Wow, this has really turned into a much easier problem than I thought. Now let's combine our like terms. So 8 plus 60 would be 68 plus 30 would be 98 plus 1 would be 99. Now be careful with your radicals here, okay? You've got a negative 24, a negative 40, and a negative 6. That should be a negative 70 square root of 2. Negative 70 square root of 2. 64, yeah, negative 70 square root of 2. So I have now taken this whole expression, I broke it down to this right here, and then I simplified that down to this right here, okay? So here's what I have. See if this makes sense. I'm taking this expression minus this expression. Now this first expression right here, I already wrote it right here. Then notice I put a minus sign, and then I put parentheses. That parentheses is waiting for this right here to come over, all right? Now, this negative sign goes for everything inside the parentheses, so we would have 99 plus 70 square root of 2 minus 99 plus 70 square root of 2. All right? And 99 minus 99, those will cancel out, and square root of 70, or 70 square root of 2 plus 70 square root of 2, remember you combine the outside numbers, would be 140 square root of 2. Now this assignment's taken quite a while, but we're done now with the hard ones. The rest of them are much, much easier. They really, really are. Okay, so with that in mind, be encouraged. Let's move on now to number 21. Now in number 21, they're asking you to find simply the third term, and we're taking a plus b to the 7th power. Now listen to me carefully, students. I taught you a formula to help you find the coefficients of a term so you don't have to use Pascal's triangle. But guys, you should have Pascal's triangle written somewhere in your notes. If we're only taking a plus b to the 7th power, I'm using Pascal's triangle. To me, that is not slow. That's fast. I just need one more row right here. So 1, 7, 21, and I'm going to stop right there because that's all I need is a third term. Just trust me. I'm taking a plus b to the 7th power. If I were to continue this row going out right here, I would have 8 numbers. So this is the right row for a plus b to the 7th power, and I only want the third term, so I just went over 3. There we go. The third term has a coefficient of 21. I mean, it's okay to use the formula that I gave you, and we're going to use it, believe me, but not on this problem. So the third term has a coefficient of 21, right? Now the first term would be a to the what? 7th. So the second term would be a to the 6th. The third term would be a to the 5th. So I'm going to go ahead and put a to the 5th. And now the b's easy to figure out because remember your exponents right here always have to add up to whatever this number is right here. So as soon as I realized I have a to the 5th, then I know my b has to be b squared. There. That's the third term, just like that, okay? Now that's pretty easy, and we're moving on. Number 25, they want us to find the 12th term, and we're taking a minus 2 to the 14th power. Now I don't feel like writing Pascal's triangle out that far, okay? So we're going to use the formula that I taught you to use to find the coefficient. And remember, the formula is this. Whatever your power is right here, that goes up top, all right? And then whatever term you're finding, you subtract 1 from that, and that's going to give you an 11. Now let me quickly go over this one more time. The top number here is always this number here, okay? And the bottom number is always 1 less than whatever term you're trying to find. We're trying to find the 12th term, so k minus 1 is 11. Now what this means right here, and sorry I had some work here I'd written out while I paused the video. Let me erase that. Okay, now so I now would have 14C11, which would simply mean this right here, over, and whatever number is right here you put down here. Now you should know by now how to type this into your calculator. You're taking a group of 14 and finding how many permutations you would have that have 11 in each group. That would be 14 times 13 times 12, 11, 10, 9, 8, 7, 6, 5, 4, okay? And if you do all of that correctly up top and then divide it by 11 factorial, you will get 364. Okay, so real quick I'll try to explain this top again because there's an 11 here. That's like putting 11 blanks. I'm not going to do that for you, but 11 blanks, and then you would start with 14, 13, 12, all the way down to your last number, which would be a 4, by the way. And then if you divide that by 11 factorial, you will get 364. So just like that, we found the coefficient, 364. Now, can I show you something, please? We are trying to find, think about this, we are trying to find the 12th term. Now please listen to me and watch this. The first term would be a to the what power? 14th, right? The second term would be a to the what? 13th, right? We descend. The third term would be a to the what? 12th. Do you not see a pattern? When you add these two together, you get 15. When you add these two together, you get 15. When you add these two together, you get 15. So instead of counting all the way down to the 12th term, let's just put dot, 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 and now let's jump to the 12th term. Well, just like all these had to add up to 15, if I'm at the 12th term, then that means I'm going to have a to the third power. It has to add up to 15. So you can look for patterns like that to save you writing all these terms out. Now, if I confuse you there, then feel free to write all the terms out real quick. a to the 14, 13, 12, 11, 10, 9, 8, all the way down. You will see the 12th term is a to the third power. A to the third power. Now, next I'm dealing with a -2, correct? So I'm going to put parentheses and put a -2. Now, remember, I know right away if A is to the third power, then this has to be to the 11th. Oh, where'd that come from, Mr. Earhart? Remember, guys, these two exponents here are always going to add up to your original power. Always. Let's look at the last problem that we did right here. 5 plus 2 is 7, and here's your exponent right here, 7. All right? So, I know my two powers are these. So really what I have is 364 times a cubed times -2 to the 11th power. And if you type that in correctly, you will get a -2048. So if you take 364 times a cubed times -2048, you will get -745,472 a cubed. That's not near as bad as the other problems that we did, all right? Number 29. Now they want us to find the middle term. Now just stop and think for a second, guys. Come on, look. If the number here is 10, then how many terms do we have going across? 11. So if we have 11 terms, what's the middle term? Wouldn't it be the sixth term? I mean, think about it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 1, 2, 3, 4, 5. Here's 5 terms here. 1, 2, 3, 4, 5. Here's 5 terms here. So my middle term is right here. If I'm raising 2u, 2u, -3v squared to the 10th power, that means I'll have 11 terms, so the middle term is the sixth term. So instead of saying I'm looking for the middle term, I think it would make the problem a lot easier if we just said we're looking for the sixth term. And I am going to go ahead and use A's and B's on this one, okay? I'm going to put A plus B to the 10th power, and we'll substitute these in later for A and B. All right? Okay, so I have A plus B to the 10th power. Got it? So I'm trying to find the sixth term. Now, if I'm taking this whole thing to the 10th power, I really don't want to use Pascal's triangle. So I'm going to find my coefficient very quickly. Remember, whatever your original power is, you put here. And whatever term you're dealing with, you subtract 1. So really what I have is I'm dealing with a combination problem. And of course, to solve a combination problem, it would be this right here. Alright, so up top I would really have 10 times 9 times 8 times 7 times 6. I would put 5 blanks and start with 9 and count down all over 5 factorial, 5, 4, 3, 2, 1. We'll see my 2 becomes 1 and this becomes a 3. My 3 becomes a 1 and this becomes a 1. My 4 becomes a 1 and this becomes a 2. My 5 becomes a 1 and this becomes a 2. Now, that helps a little bit. 2 times 2 is 4 times 9 is 36, and 36 times 7, as long as I'm not making a mistake here, I believe, is 252. So there, I just found my coefficient. And again, I go fast. You might have to pause the video there and write that down, and that's fine, but I'm going to keep moving. The coefficient is 252. Now, now I'm dealing with the sixth term, right? The sixth term. So I know my first term was a. My first term was a to the what? 10th. My second term was a to the what? 9th. It looks like these are adding up to 11. So dot, dot, dot. If I'm trying to find my sixth term, that would have to be a to the what? 5th. They have to add up to 11, so I know I have a to the 5th, okay? Now, what is my b going to be to? Well, my b is going to be to the 5th, right? Because these two numbers here always have to add up to my original power. So I know I'm going to have b to the 5th. So there we go. I did it. Now all I have to do is make my substitutions, excuse me, and I'm close to being done. So here we go. I have 252 parentheses 2u to the 5th power parentheses -3v squared to the 5th power. This is not difficult at all. I have 252 times, okay, 2 to the 5th power. that would be 32 u to the fifth. 2 to the fifth is 32, u to the fifth is u to the fifth. Times, now I'm going to keep my parentheses, I got a negative number here, negative 3 to the fifth power. That's negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So we got to be careful there. You're going to get negative 243 v to the 10th power. A v squared raised to the fifth, you multiply a power times a power, gives you v to the 10th. So I have 252 times 32 times negative 243. All right? Now let me quickly do that in my head. I'm just kidding, of course. I'm using a calculator. And what you're going to get is this right here. Negative 1,959,552 u to the fifth, v to the 10th. And there we go. Let me check my answer key real quick and make sure we got that one right. And miracle of all miracles, it looks like we did. Okay, let's move on now to number 31. Now 31 through 34 are probably the easiest ones in the entire assignment, so we're really going to enjoy these, I believe. Determine the number of subsets of each of the following. That means the total number of subsets. Well, if I have, number 31 says I have 7 elements, or in other words, 7 objects, okay? So if I have 7 objects, and I want to know the total amount of subsets of sets of 1, sets of 2, sets of 3, sets of 4, all the way through, you simply always use the number 2, and you always raise it to the power of the number of elements that you have. So it's 2 to the 7th power, which is 128. Wow, that is really easy. Number 32. On number 32, we're dealing with 6 members, okay? Now they want to know how many subsets, total subsets we can get out of that. Sets of 1, total sets of 1, plus total sets of 2, plus total sets of 3s, etc., etc. Well, you always use the number 2, and you raise it to the power of how many objects you have. So 2 to the 6th power would be 64. Okay, very easy. Number 33. Number 33, we have 24 letters, so we have a set of 24 Greek letters, and they want to know how many total subsets I can get out of that. Well, you always use the number 2, and you raise it to the power of how many objects you have. So 2 to the 24th power would be 16,777,216. There we go. Moving right along. Number 34. All right, number 34, we have 26 letters in the English alphabet, in case you were not aware of that. And so how many total subsets can I get out of a group of 26? Well, you always use the number 2, and you raise the number 2 to the power of how many total objects that you have in your group. And 2 to the 26th power would be 67,108,864. Let me get a quick drink here. And we're moving on. I told you those were the 4 easiest. And now I didn't mean to lie to you guys. I made a mistake. I told you that on the first 5 we were done expanding. I did forget about these, but we'll do these pretty quickly. You're just using i's and 3, so it really should not be bad at all. So let's quickly expand number 37, okay? 3 plus I to the 5th power. We'll talk about the directions stating to use I squared equals -1. We'll talk about that in just a second. Okay, right now let's just go ahead and expand this. So I'm dealing with the 5th power, so I want the row that has 6 numbers, and that would be this row here. Hopefully I can pull it out successfully. Good. And now let's get rid of this. So there's my coefficients right here for 3 plus I to the 5th power. So I've got my coefficients. And now let's go ahead and get our powers going. So what I have here, I don't need to make a substitution. My first term is 1, and then I would have 3 to the 5th power, because I have a 3 right here, plus, put a check mark here, plus 5, so plus 5, and then of course I would have 3 to the 4th power and 1 to the 1st power, and then plus, put a check mark, we'll put a 10, and then we would have 3 to the 3rd power, 1 to the 2nd power. Notice my 3's are descending in powers, 5, 4, 3, and my 1's are ascending in powers. So then next, put a check mark, I would put a 10, and then a 3 squared, and then a 1 cubed, and then plus, put a check mark, 5 parentheses, 3 to the 1 power, 1 to the 4th, and then plus, put your check mark here, 1 parentheses, 1 to the 5th power. I said 1 all the way through, didn't I? That's so funny. I'm getting old these days. That's all of these ones are i's. Sorry about that. All of those ones are i's. I apologize. Okay, 1 times 3 to the 5th power would be 125. 3 times 3 times 3, or 3 to the 4th power, 3 times 3 times 3 times 3 gives us 81 times 5. So 3 to the 4th power is 81 times 5 is 405. So I have 405 I, and then 3 times 3 times 3 is 27, times 10 is 270, so I would have 270 I squared, and then 3 times 3 is 9, times 10 is 90, so I'd have 90 I cubed, and then 3 to the 1 power is 3, times 5 is 15, so I would have 15 I to the 4th, and then plus 1 times I to the 5th is just I to the 5th. Now, I'm not going to get into a long detailed explanation on this. In Algebra 2, we should have covered that I squared equals -1. I'm not going to get into a long explanation except to say this: the square root of -1 is always represented by 1, so if you square both sides you get -1 equals I squared. That's all I'm going to say on that. If I lost you there, all you really need to know is this: look at the directions in this for this problem, and you'll see it says I squared equals -1. So here's what they want you to do. See this I squared right here? They really want you to put 270 times -1. And see this I cubed? Now be careful. Watch what they want you to do. They want you to put plus 90. Now watch what I do here. I, and then I squared. Now that's the same thing, guys. Look. I times I squared is I cubed. So because you had 3 i's, they want you to write 1 I and then write 2 i's. And why would you do that? Because now for I squared you would put what? -1. Now think about it. For 15 I to the 4th, they're going to want you to put what? I squared, because I squared times I squared is I to the 4th, and since you have 2 I squares, now what you're going to put would be -1 for one I squared and -1 for the other. And then they want you to put plus. Now think about it. I to the 5th, wouldn't that be I squared I? Sure it would. I squared times I to the 1 is I to the 5th. So for this I squared we put a -1. For this I squared we put a -1. So we really have -1, -1, and then an I. So here's your final answer. This is really not that bad. Your final answer is 125 plus 405 I. Now, next term we have 270 times -1. So -270. Now here we have positive 90 times -1 times I, or positive 90I times -1. That's going to be -90I. Now I have 15 times -1 times -1. Well, -1 times -1 is 1, and 1 times 15 is just 15. Now I have -1 times -1 times I. -1 times -1 would be positive 1 times I, so a positive 1I, or just I. And now combine your like terms. I have 125 minus 270 plus 15. Those are like terms. So 125 minus 270 plus 15 is going to give me -130. So I combined those terms. I got a -130. Now you have I terms. Positive 405, -90, and a positive 1. Even though you can't see it, there's a 1 there. All right. So if I have 405 minus 90 plus 1, I'm going to get 316. All right. Positive 316. Now I'm not going to redo a whole video for a little wee mistake that I made somewhere, but as I look at the answer key here, this -130 for them, they're getting a 12. So I'm wondering if somewhere I've not made a mistake, and I really don't want to have to go through and try to find that. Um, and I think it might be with the 90, I believe. And I apologize, guys. I don't want to. No, I think that's right. I'm trying to find all my little. See if I've made a mistake here. I squared, I squared. Well, I hope that I've not made a mistake. Very rarely is the book wrong, but they're getting in the book a negative 12 plus 316i. All right, and I'm getting for my answer, and I'll tell you when I'm wrong. Okay, I don't mind admitting that. I'm not going to redo a whole video for one little mistake, but I'm getting this. So if you're getting this right here, there's a very good chance you're right, and somewhere I've made a mistake, and I do apologize for that. And I don't want to make the video too long. I'm going to real quick take 10 seconds and look this over. 5, 4, 3, 2, 1. This would be 1, 2, 3, 4, 5. I to the fifth, I to the fourth, I to the third, I squared, I. It's probably such a really obvious mistake. Well, I cannot find it. But anyways, the procedure I've used is correct, and this is how you would solve this, okay? All right, last one, and we're finally finished. All right, so first of all, we're dealing with the fourth power, okay? Square root of 2 minus I to the fourth power. So that means I want the row that has 5 numbers, one more than 4, and that's the row that has 5 numbers. So let's pull that out very quickly if we can, and then let's go ahead and get rid of that. So there would be my 5 coefficients. Whoa, we don't want that, do we? There's my coefficients. And of course, I'm going to use A for this and B for this. So very quickly, I'm going to put 1 A to the fourth plus 4 A cubed B plus 6 A squared B squared plus 4 AB cubed plus 1 B to the fourth. There we go. And now for my A to the fourth, I'm going to put 1 parentheses square root of 2 to the fourth power plus 4. And then I would have square root of 2 to the third power. For B, I would have negative I. I got to be careful there, it's going to be confusing. I wonder if I had a negative I in the last problem. I did not. Okay, a negative I to the 1 power plus 6 for A squared. I'm going to put square root of 2 squared. For B, negative I squared, and then plus 4. For A, I'll put square root of 2. For B cubed, I'll put negative I to the third power plus, and then 1 parentheses negative I to the fourth power. Wow. Okay. Now, first of all, let's start with our first term here. Obviously, we're going to have 1 times square root of 2 to the fourth power. Square root of 2 to the fourth power is just 4. Okay. And so I would have 1 times 4 is 4. Type that in your calculator, and you'll see the square root of 2 raised to the fourth power is going to give you 4. And then down here, let's quickly simplify, students. Square root of 2 to the third power. We've done quite a few of these now, guys. It'd be square root of 2, square root of 2, square root of 2. Square root of 2 times square root of 2 is 2. Bring down your square root of 2. So square root of 2 to the third power is going to give you 2 square root of 2. So I have 4 and then 2 square root of 2. And then negative 1, negative I to the 1 power is just simply negative I. So 4 times 2 is 8. Times the negative I would be a negative 8I square root of 2. 4 times 2 times negative I, negative 8I square root of 2. All right. Now, let's move on to our next expression here. I'll kind of cross this off so we're not confused. All right. Now, square root of 2 squared is 2. So I really have 6 times 2 times, now negative I to the second power means negative I times negative I, which is I squared. So I would simply have I squared. Okay, so I'm going to go ahead and do this. Probably isn't the best, but I'm going to go ahead and put a negative 1 now instead of doing it later. So for I squared, I'm going to put a negative 1. So I really have 6 times 2 times negative 1, which would give you a negative 12. A negative 12. Move this down so we have space to work. And let's continue on. Okay, 4 times square root of 2 would be 4 square root of 2. All right, and then be careful here. Now we have negative I written to the third power. All right, now negative I to the third power would just simply mean this. I'm going to kind of make it really long and make sure it makes sense. Okay, over here when we had negative I squared, I wasn't too worried about that because it was an even exponent, and a negative times a negative is a positive. But here with an odd exponent, let's be really careful. 4 times square root of 2 is 4 square root of 2 times what? Times negative I times negative I times negative I. Alright, so what I really have is 4 times negative times negative times negative would give me a negative 4I cubed square root of 2. Let me go over that again. Negative I to the third power, so I wrote the negative 1 3 times. Okay? Now, having done that, I then have a positive 4 times a negative is a negative, times a negative is a positive, times a negative is a negative. So negative 4I cubed square root of 2. Now don't forget for I cubed, here's where it gets really confusing, but if you'll watch, I can explain this. For I cubed, I really want to put what? Remember? I squared I. Why, Mr. Earhart? Because look in the directions. They want us to remember that I squared equals negative 1. So everywhere there's an I squared, we're supposed to put negative 1. So if I have I cubed, I'm going to break that down into I squared, I squared I. And then for I squared right here, I can really put a negative 1 times I square root of 2. So negative 4 times negative 1 is 4 times I is 4I. So positive 4I square root of 2. There we go. And now I'm down to my very last term here. Let's be careful with this, okay? I have a positive 1. Now, because I have an even exponent, this is really ends up just simply being a positive I to the fourth power, because a negative times a negative times a negative times a negative is a positive, and I to the fourth is I to the fourth. So now I really have 1, and then what? I squared times I squared, because I to the fourth is I squared. Then everywhere there's an I squared, we put a negative 1. So I really have 1 times negative 1 times negative 1, which is 1. Okay? 1 times negative 1 is negative 1 times a negative 1 is a positive 1. Almost dropped my calculator there. Okay, now let's finish the problem. We're finally finished. Oh my goodness. Okay, so I've got 4 minus 12 plus 1. That's going to give you a negative 7. All right, then you have, now I'm going to look carefully, you have a negative 8I square root of 2 and a positive 4I square root of 2. Well, a negative 8I and a positive 4I would be a negative 4I square root of 2. Remember, when you're combining radicals, you combine just the outside numbers as long as your radicals match, and they do. Square root of 2, combine the outside numbers, and you get this right here. All right, and thankfully that's what the book has. Now the book, so we actually did this one right. Now the book takes their I and they put it at the end, and I have no problem with that. Most books do that. I don't care for that because sometimes it looks like the I's under the radical, so I squeeze mine here. I really don't care. It's all the same thing and it doesn't matter. Okay, and that's been the homework help video. I know it's been a difficult homework assignment, but I hope this has been a help to you. If you have any questions, call or email.